The Amazon biome is home to around 40,000 species of plants, 427 species of mammals, 1,300 species of birds, and 400 species of amphibians. However, the lives of all of these species is endangered because of 1,400 trees that are being cut down in the Amazon rainforest by the minute. A very good afternoon to everyone present here. We are the team responsible for predicting deforestation in the Brazilian Amazon. Our project partners are UN-RED, and we are glad to have them both here. UN-RED is a collaborative organization that strives to reduce emissions and deforestation effects in developing countries. The main goals of our project encapsulate forecasting deforestation in the Brazilian Amazon region, identifying the key drivers of deforestation, and then visualizing our findings through an online Google Earth engine-powered application. Naturally, such a demanding problem necessitates the fact that we were not the first to think about it. There has been a trove of previous work done, and we scoured through a lot of this literature in the past. What we observed was that the work done in the past had low flexibility, provided poor performance results, was not as flexible, and provided less control to the features, as well as provided low control over the features produced. We came up with a solution for that. Our solution does away with these shortcomings and provides a whole new solution, which is highly flexible, provides better performance results, has the ability to forecast into the future, provides better feature control, and offers a lot more interpretability. What makes our model so separate from the others in the past? What are our features that make it so special? Well, our features are our features. We categorize our features into three broad categories. These categories encapsulate provocative features, or features such as pasture quality, basically areas which are being grazed upon by cattle, and mining areas. Inhibitive features are those features that include indigenous and protected areas where deforestation is not permitted, as well as human activity-borne features like proximity to recent deforestation, forest edge density, and distance to roads. Our model workflow incorporated pre-processing around 10 terabytes of geospatial data, feeding our results into a deep learning-based unit model, obtaining model predictions, interpreting our predictions through a feature ablation technique, and then deploying our predictions and our interpretability results to the Google Earth Engine-powered application. The results for our model can be observed as follows. So through this map, the green areas represent the regions that have no deforestation. The yellow regions represent areas that have minimalistic risk of deforestation, whereas the orange and the red areas would indicate regions that have a high risk of deforestation. Another way of measuring the results of our model could be through a quantitative examination, wherein we have compared the performance of our unit model with random forest, which is another machine learning-based model, and JNR. JNR stands for Jurisdictional and Nested RED Plus Standard, which is the official UN-RED benchmark. As you can see from this figure, the normalized root mean squared error of our model is lesser as compared to the two other benchmarks. This stresses on how our model performed better than the rest of them. Another important component of our goal was to interpret the results of our model. We employed a feature ablation technique, wherein each feature's impact was deprecated and then tried to represent to the model's predictions. Based on the feature ablation technique, we found out that the three most important features were pasture quality, distance to roads, and distance to recent deforestation. Basically, anything indicative of human activity means deforestation is taking place. We incorporated our interpretability results and our prediction results to a Google Earth Engine-powered application. The Google Earth Engine-powered application also provides scope for carbon accounting, wherein we multiply the carbon biomass of a particular area with the deforestation taking place in that area, so as to give a rough estimate of the loss in carbon tons. You can also come to our poster session for a live demo of our application, and we would love to see you there. Summarizing the impact of a project includes being able to predict deforestation in the Brazilian Amazon region now, the ability to interpret our results, and then deploying them through our Google Earth Engine-powered application. We were also able to introduce carbon accounting and enable our partners to develop targeted policy decisions. Our team and I are hopeful that our tool would be really useful for you in Red, and we would be able to conquer deforestation. The earth provides enough to satisfy every man's need, but not every man's greed. Thank you very much for your time.